What's up, guys? Today we're going to go over networks and other things in the Applied Energistics 2 mod. So specifically, I'm going to talk about how you can more efficiently make storage networks, and mainly how the ME controller lets you unlock your network versus not having an ME controller. How you can automate stuff, such as this furnace I have here that is automatically smelting iron ingots, but only doing it up until I have less than 40 iron ingots left in my network. How you can make sub networks so that if you run out of channels on your ME controller, you can make a sub network and kind of delegate out your channels like that, so you can greatly expand the throughput of your entire network. So with that, let's jump right in. So if this is the first time that you're getting into the Applied Energistics mod, I have a different video that goes over a lot more of the basics of getting like your crafting recipes ready to go, where to find all the materials, how to make most of these blocks. So I highly recommend looking at that if you don't have a basic network setup already. Mainly like, for example, how to make the Fluix crystals, how to get these processors going, things like that. So highly recommended to watch that, and it's just long. Combining the videos would have been really long. So in this case, what I have here is I have a way to generate energy. Basically everything up to here is energy. These are solar panels with some pipes. It goes into basically a battery, and that goes into an energy acceptor. The energy acceptor lets it, at least in my mod pack, it lets it accept energy from other mods, and it converts it into the energy that the ME network wants to use. So that's how I'm powering my network right here. The rest of the network just has this cable. It has an ME drive with a single cell in it, as well as an interface with an ME terminal. This is all you need for a simple storage. So if you want to make this only, and you've never done it before, I highly recommend watching the other video. And this is really all you need. You can attach 7 ME drives, and it gives you a very significant amount of space. Like each one of these cells is intensely big. Like if I put a bunch of stacks of stuff in it, this is how much space it uses. I can put way more different types of things in there, and then the bytes is like the actual volume. And I can put more cells in here as well. So, they're quite large. Yeah, the terminal, you can put things in, I can take things out. This cable, as well as the fact that I don't have an ME controller, an ME controller is this weird looking thing. It makes it where my network is limited to 8 channels. And what a channel is essentially just things you have connected to your network. Like the cable has 8 channels, and you use those channels by connecting stuff to it. I think things that are energy related are exempt. I don't think the energy acceptor is using a channel, so it's still 2 channels. Yeah, because 1 channel and then 2 channel. If I were to, for example, hook up a bunch of drives like this, we can see that this is like on and operational, and this is like, looks like it's operational. If I attach a bunch of drives, it'll turn off, and then this will also be grayed out, right? And I won't be able to put stuff into it. And that's because I overloaded my network with too many things. So I bring this back down to 8, it'll turn back on, and everything will work fine. However, 8 isn't very much. And the reason it's not very much is like if you're just putting drives, you'll have a huge amount of storage already. But if you want to, for example, have a furnace automatically smelt any wood going into your network, into coal or something, you can use an import and an export bus, which I'll explain how to use later. But each one of these uses another channel. So this is a channel and this is also a channel. So with these kind of things, you can start using a lot of channels really quickly. So the way to increase the number of channels that you have is by using an ME controller. An ME controller is made like this. And basically you just attach it to your network anywhere you would like. And what it does is it allocates per face 32 channels. So this face gives you 32 channels, which means you have to use a better cable to fully utilize it, because this cable only has 8 channels. So you can only use 8 of the 32 on each face. This dense cable, or dense smart cable, will have 32. This face will give you another 32. This is another 32, another 32, and so on and so forth. You can use all 6 faces because energy is carried through cables the same way as the channels are. So you don't need to have like a cable just for the energy or anything like that. So the ME controller not only lifts the 8 channel limit on your network, but it also allocates the channels differently to your stuff. So if I were now to add a bunch of ME drives over here, and let's add 8, what will happen is we can see that our ME network is not offline. It's still operational. This is still green. This still allows me to put stuff into it. And that's because it adds channels based on kind of the distance away from your network. Your controller. So it's adding this one first. So this is channel 1, then it goes to channel 2, and then channel 3, 4, 5, 6, 7, 8. So if I were to put a storage cell in here, that would work perfectly fine. But it's getting limited by the cable now. The limit of 8 on the entire network is lifted because we have a controller, but the cable can still only handle 8 channels. So the ones at the end here do not work. So like we have this one is off. So if I put I didn't mean to do it. If we put a cell in there, we can see that that one's off and this one's on and operational. So we need to get better cable if we wanted to do this. But the nice thing is that it doesn't turn off your entire network entirely. This can be lifted by just using a better cable for the first 2 channels, because it's not like the cable gets overloaded. It's just necessarily can't read the other 2 because it's limited. But if I were to use a dense cable, which can use or can have 32 channels, and I connect it to the first 2 things, because of how it allocates the channels, where it kind of does it in a distance orientation, these 8 things are connected to this cable, which can hold 8 channels. And then we connect those 8 channels to something that can hold 32. And then we add one more thing, so now that's 9. And if you've seen the top left, the smart cable and the tooltip will tell you how many channels that you have are being used. So I have 9 out of 32 here. And then this one gets added in, so that we have 10, and then that goes to the controller. So you don't need to increase the entire bandwidth of all of your cables either. And this gets particularly useful for subnets when you don't necessarily need a lot of channels, but you need to go over vast distances. But just be aware that your bandwidth is limited based on the number of cables. And if you go over 32 on one of these faces, you're going to have to bring another face out like this and connect things, new things to this thing. Now, the ME controller is a unique block in that you can only have one ME controller, not necessarily a block, but as an entity on a single ME network. So if I were to attach a separate one over here, we can see that they turn red because you can't have more than one. It'll completely break both of them. But what you can do is add more ME controllers to another one, and you can make a bigger, better ME controller. There are limits to how you can build the multi-structure block. I believe one of them is that it can only have a length of 7 in one direction. So this is 7. If I add one more, it'll break. I can add 7 in this direction. So 1, 2, 3, 4, 5, 6, 7. And then if I do 8, it'll break. And then again up here, 1, 2, 3, 4, 5, 6, 7. One more up here will also break it. I believe there's also limitations to how many ME controller blocks you can have on each side of one. I believe the limitation is 4, or maybe it's 3. So if I were to make a cube, and sometimes it'll shut off while you're building stuff just because it takes power, and I do something like this in the middle, what we'll see is that this one right here turns off, and that's because it has more than 3 things connected to it. I'm not sure if 3 is the limitation, because like it doesn't turn off like this, which is weird to me. Because this has 1, 2, 3, 4. I believe it's if there's 4 things, or 3 or, more than 3 things in a single plane, if that makes sense. So this is a plane, right? But like this is fine because there's only 3 in the plane and then there's 1 out of the plane. But 4 in the plane will not work. So you want to be careful of that. This, each block still has 32 channels per face. So like this one's 32, this is 32, that's 32, etc., etc. And you only need to power it using 1 energy block. So the whole thing's getting powered still just from this one little thing. But this is how you get a very, very large number of channels. But it has to be connected. You cannot have 2 separate disconnected ME controllers because it'll break both of them. Now things start getting very interesting when we want to start automating certain processes such as like smelting and things like that. The way you do that is you use import and export buses. The import bus, it's whatever you're doing to the network. So the import bus essentially goes from the machine to the network, and the export bus comes from the network to the machine. So if I grab some of the cables, and this is the not dense cable because you can't put the import and export buses and some other things on the dense cable. So I'm using the non-dense cable, and it has to match the color, or they won't connect to each other. If I do that and I add a furnace here in the middle, what I can do is put an import bus on the side, I believe, or maybe the top. Each machine is different, and the side that you put the import and export buses on matters. I don't remember what they all are for everything, but just know that if it's not working, try a different face. I'm going to try putting the export bus on the top here. And then what you do is you right click into it and you put a filter of some sort. So I want to export, say, iron ore. So I just click iron ore into there. It doesn't take an iron ore. It's just adding a filter. There's a bunch of different like modules here. And those do different things. We don't really need to worry about any of those right now. Just briefly though, they modify things such as the amount of filters you can have, the speed. I'm trying to find where they are, as well as just other things. They're like these cards, right? Like inverter cards. If you want to add redstone capabilities, or if you give it a redstone signal, either through one of these things or just a normal redstone signal, you add a redstone card to it, so you can disable it with a redstone signal. Things like that. Just all of the different cards handle it. So I'm moving it to the top, and I put iron ore on the filter. So if I put iron ore in here, we'll see if it goes into the furnace, which we see that it does. It goes very slow, FYI. That is why you might want an acceleration card, just so that it goes faster. Like if I take an acceleration card and I put it in here, it'll go way faster. So, you know, keep that in mind. If it doesn't need to be fast, then whatever. And then we go on the side, I think, maybe. And we do coal for the fuel. And maybe that's the bottom. I don't know. We'll find out. Does that go in there? Yes, no? Yes, it does. Okay. And then to get it out, we might be able to go on the side also, and it might be the bottom. We're using an import now, so I'm using an import, and then I connect it to my cables, and I get rid of that one, like that. This doesn't require a filter, I believe. It'll just pull anything out that it can, and it might need to be on the bottom. So let's try the bottom instead. Okay, so it needs to be on the bottom. So the output's on the bottom for furnaces specifically. And we can see now that we're fully automating the thing. I don't know why, but it seems like at first when you attach the exporters, they go really slow, as we saw, but then they speed up, as we just saw the coal all go in there really fast. I don't know why that is. It's not as slow as it was at first. It's still pretty slow, but it's not quite as slow if you wait a minute. But now we can see that every time we put iron ore into the terminal or coal, it'll automatically go into our furnace and turn into whatever it would turn into. This can go for any machine, even other modded machines, assuming you have a mod pack with good cross mod patches going on and stuff. And if you don't, I think there's ways to work around that. So like, for example, I could do one of the mechanism machines and automate something. I've automated before the enrichment chamber, which I have no idea where that is, but that's essentially what has 3 inputs and stuff. You can automate any of these things. You can automate any of the tech reborn things, any of the thermal expansion things, etc., etc. So that's very useful. However, you're probably thinking, well, what if I don't want it to use all of my coal? Or like, what if I don't want it to use all of my iron? Like if I want a stockpile of iron or something, and this is probably more prominent if I have like iron ingots and those are getting crafted into something else. Like in particular, if I have Tech Reborn, if you smelt an iron ingot, it turns into I forget what it's called, like some other different type of iron ingot. I don't want it to use all of my iron, but I want to have a stockpile of both. So the way to do that is what I've already kind of mentioned, is that you can use a redstone card. So first I will grab a redstone card from the thing, and I'm going to put it in this top one where the iron ore is going in. And I'll even turn it to actual iron ingots just so that we can see exactly what I'm looking at. So if I turn this now to iron ingots and I take out this thing, and then put these in, oops. You know, this will turn our iron into whatever the Tech Reborn version is. Refined iron ingot. All right. So we don't want to using all of the iron. We want to keep some iron for ourselves. So I put a redstone card in this top thing already. This thing is that it's always active, or it's active without signal, or active with signal. I usually do active without signal. So when there's no signal, it's active. So right now it's active. But then if it gives it a signal, it'll turn off. And then what we can do then is add more cable directly next to it. And we don't want it to connect. Specifically, don't want it to connect, and I don't know. I might have to... This is always awkward. It doesn't connect if you have the thing on it. What we want is a ME level emitter made with a calculation processor and a redstone torch. I might have to redo that thing. What we do is we have it face into where our thing is going to go. And then we put our export bus back on it. And now we can see it's not connected. I wasn't sure how to do that without breaking it, but you might just have to break it and redo all the filters and stuff. And then active without signal. So this thing is just on. But what we do is we right click on it. And what we can say then is I could say level type and it's item or redstone mode emit when levels are above or equal to limit or whatever. So this thing, I want it to be when my iron is, let's say I want to keep like a stockpile of 40. It says emit when levels are above or equal. So right now we have 25 iron ingots, so the signal turned off. I want it to go the other way, because if this is off, this is turning on and it's still going to use it. So either we want to flip what this is doing, or we want to flip what this is doing. I personally like to see it so where if this is on, it's working, and if it's off, it's not working. So I'm actually going to flip this one. So it's active with signal. So right now it's off. And then if I add iron ingots, so it goes above the limit that I set, it'll turn back on. And really you just have to read it. And you can just like, you either read it or you just test it out and make sure like you set my limit to 40 or whatever, and I read this. But if I just want to test it, I just go in here and take it all out and it's off, and I put them all back in, and then it turns on again. However you figure out how to do that. And then you can test to make sure that this is or is not working when you want. So it's active with signal, which it has a signal, and the signal's on when it's above 40. So when it reaches less than 40 iron ingots, it'll stop using my iron, right? And that's what we want. It'll have a stockpile in here too. So like it'll use a little bit more just because it'll stockpile a bunch in here. There's probably ways to do that where you can like read the contents of the furnace, but I usually don't bother doing that stuff. So in this case, there was a way to automate it without using all your stuff. You could also likewise do the same thing with the coal, which is this one, by essentially putting a level emitter and making sure that you have enough coal, for example. And the level emitters also use their own channels. So the channel discussion we had earlier, this whole thing would be using 1 channel, 2 channel, 3 channel on the bottom, 4 channel. And that's just for the furnace stuff. Then there'd be 6 and then 7. We're fine with the ME controller, but if this was way more complicated, we would want to like have a dense cable going across the bottom, and then we break out these smaller cables just individually for each furnace, so we don't bottleneck ourselves with 2 little channels. So that's one way to automate it. Again, keep in mind that different faces do different slots. So if something's not working as you think it should, try a different face. Usually it's the top for the inputs and the bottom for the outputs, and the side for other stuff. That's a soft rule. That's not like a rule. It'll be different for every single machine. Now, something else that really lets you unlock the potential of your networks is the use of subnets. So basically what those are is you can fragment your network, and you can split up which channels are doing what by using a subnet to free up channels on your main net. And that just sounds like a lot of words, so I'll just show you what that is talking about. So let's say that this thing, I have like 10 of these things, and they're using a whole bunch of channels, and I don't want to have to run all of those channels from my main net ME controller, which might be like, hundreds of blocks away. I don't want to have to do that. I'd like to have like a local network, and then I just run a single channel over to my main one, so that I don't have to like run all of the channels, which would require 2 cables or more, and it just gets really messy. We can do that with a subnet. So if I get rid of these 2 things right here, I believe you need an ME interface and you need an ME storage bus. I never remember which direction the bus has to be. I think it's the side of the subnet. And then we attach it to the subnet. I might be wrong. This might be on the other side. So this is our main net, and this will be our subnet. What we do then, though, is when we're on the subnet no longer has power. I don't think this gets power transferred, so we need to get a way to get power. So usually what happens is I add an energy acceptor on the subnet, and I add an ME controller on the subnet as well. The reason for this is because it is a separate network, so it is required to have a separate controller, and it won't break your main net controller, and that's because essentially it has a one-directional way of like the main net can supply the subnet with storage, but the main net can't utilize any of the stuff on the subnet. The subnet has to govern itself, and it can basically export items to the main net, but that's as far as the main net is concerned. It can't like directly control any of the stuff going on there. So we need its own ME controller. I'm going to just attach a solar panel here and turn it to daytime so that we can see what it's doing. Maybe I'll attach this thing as well so that it's not not weird. That one, I think. Other one. Okay. So, set the daytime as well. So we have a subnet. We have an ME controller on our subnet, and this one is giving us channels to everything up until this bus. And then this the ME interface basically allows the two networks to communicate as far as items are concerned. These patterns are not relevant for what we're talking about. This is for like auto crafting and stuff, and I'll probably make that in a different video because that's a whole other ballpark. But essentially what we can see by mousing over this cable is that this ME interface only uses one channel. So the main network only has 3 channels, which is the drive, the terminal, and the interface. And then these channels that the furnace is using are on the subnet. Which is all 5 of them. This one counting as 1, and then there's 4 because of this thing, the thing in back, and then this thing right here. So in order to get this to communicate, we shouldn't really have to do anything else. I actually think it works already, where if I take all the iron out, it's going to move the iron back in. And I might have to... No, it's working. Yeah. So yeah, the storage bus is on the side of the subnet. So you can see that this is still working exactly how it was, where the iron ingots are getting automatically pulled in, and then the refined iron is getting automatically put back into the main net. But as far as these 2 networks are concerned, they're completely independent. So for example, what I mean by independent, because it seems like they're basically the same network, right? If I were to slap an ME drive here, I don't believe I would be able to access any of these items from the main net. Like if I have to like put items into it to then show you that it doesn't work. So I put an empty one here. I put the full one in the subnet. If I go to the terminal, now we just see nothing, right? Even though this network has the items, the furnace and stuff can still grab, I believe, the items from this thing. But on the main net, we can't see anything and we can't interact with it in any way. So the storage usually has to happen all on your main network. And the purpose of the of this thing is to have the items communicate back and forth with each other. This thing kind of just acts like a chest. Like if I just dumped items in here, I believe they just get stored directly on my main network. So this is a great way to essentially like fragment your networks. The fact that this only takes 1 channel means that, again, if this is really far away, I could actually run just like a normal glass cable like this from my controller, from my main controller over here. Like say this is my main network. I can run one of these and I can make 8 different sub networks. And each sub network has its own controller. So the sub networks can be as big as the controllers can be, which is pretty large. And I can have 8 entire separate sub networks, this being 1, attached to my main network just through this 1 cable. So this lets you get really, really high amounts of stuff all at the same time without necessarily needing a giant ME controller, which will fill up with channels if you don't fragment your network into sub networks like that. The ME interface is also very useful for other things, but this is just what you use it for subnetworks. You have to use the storage bus though. So you use both the interface and the storage bus. The interface by itself will not work, and the storage bus by itself also won't work for that. All right, guys, that'll be it for this video. I hope you're able to find the information easy to understand, as well as easy as the mod can be, which is really complicated. I hope that you're able to build very efficient networks and you have no issues with making subnets and things like that. If you have any questions, feel free to leave a comment. You can also join the Discord if you need to post images. No pressure to stay after that. You can leave if you want to. I hope you have a wonderful day, and I hope to see you next time.